God bless you and God guide you and protect and preserve you, geometry students. I'd like to share this practice test with you, and I trust God will be very, very close to us to help us and lead us. I want to start with number 9 here on the practice test, and it says, write and ponder a verse in His mercy. God gave us, and I need to correct this. Let me go ahead and just make a quick correction here. God gave us related to one specific congruence. And this congruence is related to our congruence with God. And this specific one is where He says, therefore, be merciful. Just as your Father also is merciful. So mercy is one specific attribute He wants us to show. And that's a part of His makeup. Grace is gracious, He's merciful, He's got full of goodness and so on. So say that with me. Therefore, be merciful, just as your Father also is merciful. One more time. Therefore, be merciful, just as your Father also is merciful. So He wants us to be congruent with Him in every single way. And certainly in His mercy, He wants us to be just like Him. Now, in number 10, it's got two parts to it. What does CPCTC mean? Well, I can just, and I trust many of you will be able to say it very, very quickly and loudly, that it means corresponding parts, or matching parts. Corresponding parts should be parts here of congruent triangles I know some of you would be tempted to use this symbol here, but I'd like you to also learn to write the words out. Corresponding parts of congruent triangles are congruent. So that's what CPCTC means whenever you use it. Now, when is CPCTC used as a reason in doing proofs? Any of you remember? You only use this after your congruent statement. Only after the statement, let me write it this way, of congruence between two triangles. So again, only after the statement of congruence between two triangles, only after you've done that, then you can use CPCTC, not before. If you put CPCTC before the statement of congruence between two triangles, you're going to get it wrong. So only after. Okay, let me underscore that, after. What else do we have here? We've got a proof here, and this is really, really good for you to do, and I should really say write the proof, not complete the proof, but write the proof, because you're doing this one all the way through. So here we go. What are we given? We're given that segment VE is congruent to segment LE. So I'd like you to, whenever you're given something, just stop and mark it. And here I go. VE congruent to LE. VE is over here, LE is over here. We've marked those. What else are we given? We're given that segment OE is perpendicular to segment LV. So here's segment OE, it's perpendicular. How do we mark that? I'm sure you know. Perpendicular to segment LV. So we got all the givens marked to prove that triangle LOV is an isosceles triangle. Alright? So LOV, the overall triangle. Is there anything else we can mark as we compare these two triangles, the one to the left with the one to the right? I'm sure they're not in your heads and so saying yes, we can mark. They're reflexive always. And we can also mark the 90-degree angle here, because if this is 90 and the whole thing is 180, then this has got to be 90 as well. So what do we have now? Even before writing one statement, and I really like this very much, just make sure you always make the marks, all the marks, and you'll be able to see the congruence you have. We've got side, angle, side, side, angle, side, and it has to show up for both triangles, not only for one. So we have side, angle, side for the left triangle, side, angle, side shown for the right. Now we can begin to write our statements and reasons. Statement number one. What should that be? I trust you know what it is. It's going to be segment BE is perpendicular to segment LE. In addition, we could lump them together like this. Segment OE. Okay, did this wrong. It should be congruent. Let me correct this. Trying to get rid of this perpendicular here. Let me just go back and write that statement again. Correct that mistake. Seems like it's not going away. Let's try one more thing here. It's gone. It's gone. Spare with me a minute while I get rid of these incorrect marks. That one is gone. This one is gone. This one is gone. This one gone also. That's gone. That's gone. This one is gone. That one is gone. I think I got it all now. Sorry about that. Let's start again. Segment VE is congruent to, not perpendicular to, but congruent to segment LE. Okay? What I want to do now is I want to make the statements in the footprints of the marks. So here I've got VE and LE accounted for. What else do I have? Well, I got segment OE. Is perpendicular. Here's the perpendicular. Segment LV. And the reason for those two, as you know, would be given. And remember I said this to you, if you can't get the givens, God help you. But He will. He stands ready to help you. So what have I done so far? I've accounted for this one pair of sides, LE and VE. So that's done. And bear in mind that my last statement is going to be side angle side. My last reason rather will be side angle side. Okay, that's where I'm headed. So let's see what else I can do. In the footprints of the mark right here, I can write that segment OE is congruent to segment OE. Reason? I trust I have a lot of people shouting, reflexive prop. Yes, that's your reflexive prop. And that takes care of the second pair of sides. So I got first pair, second pair of sides, and I just need to take care of the angles. Because I'm heading for side angle side. So here I go. I can say that angle, this angle at E, which is LEO. Please don't call it angle E. What angle LEO is congruent to this angle here. And again, that's not angle E, because E could be here, E could be here, E could be the straight angles. Let's call it OEV. Angle OEV. Why would that be true? All right angles, or all righteous angles are congruent. Are congruent. So I've got it all. I've got this pair of sides accounted for. I got this pair of sides accounted for, and I've got the angles accounted for. So I'm ready now to make my conclusive statement. So here it comes. Triangle. One to the left here. I'm going to call it LOE. Is an identical twin with, or is congruent to, one to the right. I'm going to name it properly. VOE. VOE. What's going to be the reason? I'm sure I can almost hear the sound like cheerleaders saying side angle side congruence. Certainly, that's where we were headed all along. Side angle side. Now that we've got congruent triangles, we can go ahead and make a statement related to CPCTC, because remember I told you here that when is CPCTC used as a reason in doing proofs? Only after the statement of congruence between two triangles. So here it is, we have it, statement of congruence between two triangles. Now we can use CPCTC, and here we're going to use it related to angle L and angle V. So we can say angle L is congruent to angle V. Why? CPCTC. CPCTC. They are corresponding parts of congruent triangles. So I'm just going to put the marks here lightly, because it wasn't given. We're just finding out that they are, because we have congruent triangles. And now that the base angles of this overall triangle are congruent, now we can say the triangle is isosceles. So the next step would be to say the overall triangle LOV is isosceles. Reason? Definition of an isosceles triangle, because every isosceles triangle has the base angles equal, right? Definition of isosceles triangles. So that's the way to do that. Again, make sure you have your statement of congruence between two triangles first, and then you can use your CPCTC. And once the base angles are equal or congruent, you can say the triangle is an isosceles triangle. Okay, that's a good one. I'm glad we got to go through that one together. Let's take a look at what else we have. And we've covered all of this before. That proof, I trust you'll be okay with it. Let's go back. uh,